The human octopus genome. Two species worlds apart. One walks the land and builds machines, the other drifts in the sea, shape-shifting, solving puzzles, changing color like thought made visible. Yet when scientists sequenced its DNA, they found traces of us. How can a creature with 3 hearts and blue blood share the molecular language of the human mind? In 2015, a group of geneticists launched an ambitious project to map the full genome of the California two-spot octopus, Octopus bimaculoides. They expected something simple, something fitting for a mollusk. Inside that strange liquid creature, scientists found over 33,000 protein-coding genes, more than in humans. Even more surprising, many of those genes are linked to brain development, learning, and memory. The same molecular tools that shape the human mind appear in a different form, beneath the skin of an octopus. One group of genes in particular caught attention: protocoderins. In humans, these regulate how neurons connect and organize, essential for memory and complex behavior. Octopuses have an even larger and more diverse set. Another group, called zinc finger transcription factors, plays a role in controlling how DNA expresses itself. Here too, octopuses show massive expansion, as though their genomes had independently evolved to support creativity, problem-solving, and flexibility. The deeper scientists looked, the stranger it became. An octopus's intelligence isn't centralized like ours. 2/3 of its neurons sit in its arms. Each arm can taste, touch, and even decide independently, almost like 8 semi-autonomous minds working together. A human brain runs the body. An octopus body is the brain. Biologists tried to explain it through convergent evolution, the idea that different species, under similar pressures, can arrive at similar solutions. But then came another surprise. Octopuses edit their RNA at a massive scale, reprogramming how their genes function, not just over generations, but within their own lifetime. That kind of flexibility is almost unheard of in multicellular life. Their genome isn't static. It's alive, adapting in real time. Between 2018 and 2022, new comparative genomic studies deepened the mystery. Researchers found hundreds of shared genes related to neural plasticity and serotonin signaling, mechanisms crucial for emotion, learning, and adaptation. Humans and octopuses, separated by 500 million years of evolution, somehow share the same molecular foundation for cognition. One team jokingly called the octopus genome alien, not because it came from space, but because it defied evolutionary expectations. It looked foreign to everything else on Earth, yet eerily familiar at the same time. Of course, genetic similarity doesn't mean shared ancestry beyond life's ancient root. Both species evolved on the same planet, under the same laws of biology. Still, the overlap stands as a quiet reminder. Intelligence may not be rare at all. It may be what the universe naturally builds again and again when given the chance. The monarch migration and the solar cycle. They weigh less than a paperclip, yet every year they cross a continent, and their greatest journeys rise and fall with the rhythm of the sun. Each autumn, across North America, millions of monarch butterflies begin a migration unlike any other. From the forests of Canada and the northern United States, they travel nearly 3,000 miles south to a few mountaintops in central Mexico. They gather there by the millions, covering the trees in a living rust-orange canopy. What makes the journey extraordinary isn't only its distance, but the precision. The butterflies that leave the north never make it back. They die along the way. It's their great-grandchildren who complete the return trip, somehow following the same route to the same groves year after year. Scientists have long searched for how these fragile insects navigate so unerringly. Their antennae contain cryptochrome proteins, light-sensitive molecules that respond to both sunlight and the Earth's magnetic field. This gives monarchs a built-in compass, allowing them to orient even when skies are cloudy. In 2014, researchers confirmed that when these proteins are disrupted, the butterflies lose their ability to migrate in the correct direction. But another discovery hinted at a deeper connection. In the 1990s, entomologists tracking long-term data noticed a curious pattern. Monarch populations seem to rise and fall with the sun's 11-year solar cycle. During solar maximums, when the sun's magnetic field flips and solar radiation peaks, monarch numbers soared. In the quiet years between, their migrations thinned. A 2020 study in the Journal of Animal Ecology found that the pattern held across multiple decades. Migration densities correlated with solar flux and geomagnetic activity, suggesting that solar variation might subtly influence monarch survival or orientation. The mechanism remains unknown. Perhaps shifts in solar radiation affect weather patterns along migration routes, or alter the geomagnetic cues the butterflies rely on. Whatever the cause, the data reveal an unmistakable rhythm, one that connects a species' flight to the heartbeat of the star that sustains life on Earth. If true, it means the monarch's navigation is tuned not just to Earth, but to the sun itself. Every wing beat, every course correction, may follow a pattern shaped by solar energy pulsing through the planet's atmosphere and magnetic field. Evolution through millions of years may have wired these insects to move in synchrony with a cosmic rhythm we rarely notice. And so the migration continues, delicate wings tracing ancient routes across a continent. The butterflies that return to Mexico have no memory of the journey, but their species does. The Einstein and Tesla connection. They never met. They worked on opposite sides of the world. Yet their ideas bent the same fabric of reality, space, time, and energy itself. Two men chasing the same mystery from opposite directions. It begins at the turn of the 20th century. In New York City, Nikola Tesla stands in his laboratory, surrounded by coils taller than a man, the air alive with violet arcs. Across the ocean, in a quiet apartment in Bern, a young Albert Einstein sits at his desk in the Swiss patent office, scribbling equations on scraps of paper. One man experiments with lightning, the other with thought. Neither knows the other exists, yet both are staring into the same invisible world, the nature of energy. Tesla called it the wheelwork of nature, a hidden mechanism that could be tuned, amplified, and even transmitted through the Earth itself. Einstein, not yet the legend he would become, was searching for the mathematical laws behind that same energy, how light, motion, and time intertwined. Their worlds couldn't have been more different. Tesla's was filled with metal, motion, and vibration. He built what he imagined. Einstein's was pure abstraction. He imagined what he could never build. But when their ideas finally emerged, they seemed to describe the same reality from opposite sides. In 1899, Tesla reported detecting signals from beyond the Earth while testing his high-frequency transmitters in Colorado Springs. He speculated they might be of intelligent origin, waves traveling faster than anything known. 6 years later, in 1905, Einstein published his special theory of relativity, declaring that nothing, not even information, could exceed the speed of light. One man claimed to have heard the universe speak. The other explained why it shouldn't be possible. Yet the deeper you go, the more their thinking overlaps. Tesla described energy as vibration, a rhythmic, universal oscillation binding all things. Einstein described it as curvature, energy and matter bending the geometry of space-time itself. Tesla built machines to resonate with the Earth's natural frequencies. Einstein showed that the entire cosmos resonated with the energy it contained. They spoke different languages, one of sound and resonance, the other of math and geometry, but both were describing structure. The climax comes in their final pursuits. Tesla spent his later years chasing a dream he called the magnifying transmitter, a device to wirelessly deliver energy across the planet by coupling to the Earth's natural resonant frequency. To him, the planet itself was alive with power, waiting to be tuned like an instrument. Einstein, decades later, spent his own final years searching for a unified field theory, a single equation to connect gravity, electromagnetism, and the forces of nature into one coherent field. Different tools, same goal, to reveal that everything, light, mass, thought, vibration, emerges from a single underlying order. Tesla died in 1943, alone in a hotel room. His notes were seized by the U.S. Office of Alien Property. hundreds of pages of equations and unfinished schematics. 12 years later, in 1955, Einstein died in Princeton, still working on a page of calculations for his unifying theory. Two geniuses, separated by time and temperament, both leaving their final lines unwritten. Today, historians find no record of collaboration, no meeting, no shared correspondence. But the parallel between them remains uncanny. Tesla's theories of resonance and field interaction now echo through quantum field theory and electromagnetic unification. Einstein's relativity, once thought to exclude Tesla's ideas, ultimately revealed that space itself can vibrate, ripple, and carry waves of gravity. In different ways, both men pointed to the same truth, that energy and geometry are inseparable, that the universe might not just exist, it might resonate. The wow signal. A radio telescope in Ohio captured something that shouldn't exist, a precise signal that almost looked manufactured. In the margin of the printout, astronomer Jerry Amon scribbled a single word: wow. But what if that one exclamation was beyond excitement? The strangest of all is that it has never been heard again. The question is, who or what sent it? It's the summer of 1977. At Ohio State University, a massive structure called the Big Ear points toward the stars. Its job is simple: to listen. Every night the telescope scans deep space, sweeping across the sky in search of radio waves that don't belong to nature. On August 15th, a narrow, concentrated signal appears. It lasts 72 seconds, just long enough for the Earth's rotation to carry the telescope's beam across its source. The signal isn't random noise, and it's broadcasting at one of the most curious frequencies in the universe, 1,420 megahertz. That number matters. 1,420 millihertz is the natural emission frequency of hydrogen, the most abundant element in existence. To many scientists, it's the universal channel of the cosmos. If any intelligent civilization wanted to announce itself, this is the frequency they'd choose. A wavelength every advanced species could understand. Days later, while reviewing the data, astronomer Jerry Amon sees something he can't explain. Printed across a line of numbers is a sudden spike, 6 characters that stand out from the rest. 6EQUJ5. He circles it in red ink. Next to it, he writes one word: wow. That tiny note becomes legend. For decades, scientists have tried to find the same signal again. No one has. They've scanned the same patch of sky over and over. Nothing. Whatever produced the wow signal never repeated itself. So why was it there in the first place? And why that exact frequency? Back in 1966, before the signal was ever recorded, astronomer Carl Sagan published a book titled Intelligent Life in the Universe. In it, he suggested that 1,420 millimegahertz, hydrogen's signature, was the most logical beacon for interstellar contact. More than a decade later, the wow signal arrived at that exact frequency from a region near the constellation Sagittarius. Any chance this could be coincidence? In the 2000s, new generations of astronomers began reanalyzing the data. By 2017, one researcher, Antonio Paris, proposed a possible explanation. A comet passing through that region could have emitted hydrogen naturally, mimicking a radio signal. It was a bold idea, but when other teams checked the comet's position at the time, the math didn't line up. The comet wasn't there. In 2022, a fresh study in the International Journal of Astrobiology pointed to a nearby star system, 2-mass 19281982-2640123. Roughly similar to our own sun, located in almost the exact direction the Big Ear had been listening that night. If the signal came from there, it would fit perfectly with the parameters Sagan predicted decades earlier. After nearly 50 years, no telescope has ever picked it up again. Modern instruments are hundreds of times more sensitive than the Big Ear, yet the silence remains absolute. Maybe it was a cosmic fluke. Maybe a natural burst we still don't understand. Or maybe, just maybe, we caught a signal that wasn't meant to repeat. So, if that was the first time Earth heard a message from beyond, what if we've already heard the second, without realizing it? DNA and the crystal pattern. In the spring of 1953, a paper appeared in Nature that changed biology forever. It described the structure of the DNA, a molecule built like a twisted ladder, coiled into a perfect double helix. Each rung carried the code of life, each spiral turn precisely measured and symmetrical. The discovery came through X-ray diffraction, the same method used to study the internal geometry of crystals. Rosalind Franklin's photographs revealed repeating patterns of light and shadow, a crystalline fingerprint that led Watson and Crick to their model. At its core, DNA was a mathematical structure, ordered, repeating, self-assembling, just like the minerals found in rock. Half a century later, scientists began to notice something uncanny. When they examined DNA's symmetry, its periodic spacing and helical pitch, it matched the repeating patterns seen in natural crystal lattices. Both obeyed the same rules of chemistry and energy, the drive towards stability through repetition. In both cases, structure emerged, which now raised an unsettling question. Did life borrow its architecture from minerals? To explore that, researchers turned to a process called biomineralization, how living organisms form crystal-like structures, shells, bones, teeth, coral, every one of them built by biological systems that crystallize minerals with atomic precision. Some scientists began to wonder if the first genetic material might not have been organic at all. Long before DNA, before even cells existed, certain minerals, like clay, pyrite, and magnetite, were capable of forming templates. These surfaces could attract and organize molecules, arranging them in repeating sequences. Experiments have shown that some crystal surfaces can bind amino acids or nucleotides in ordered patterns, forming primitive chemical chains. Those chains in turn could copy themselves, not through genes, but through geometry. In the 1980s, Scottish chemist Graham Cairns-Smith proposed a radical theory, that life began when crystals learned to store information. The crystal lattice acted as the first genetic code, passing on structural patterns from one layer to the next. Over time, organic molecules may have taken over that function, replacing minerals as the carriers of memory. Fast forward to 2021. A team publishing in Nature Materials compared the symmetry of DNA's double helix to the lattice spacing in certain crystals. They found that some geometric ratios matched to 5 decimal places, mathematically identical. To a few researchers, that suggested something profound. That information, the essence of life, might not be unique to biology. It could be a property of matter itself, emerging whenever atoms find balance. Of course, most scientists see it differently. They argue that these patterns arise naturally from energy minimization, atoms settling into the most stable arrangement. The similarities, they say, don't imply ancestry, just shared physics. Still, the visual connection is hard to ignore. Recent nano-templating experiments have revived interest in this idea. In labs, researchers have managed to grow organic molecules directly on crystal surfaces, step by step, atom by atom, using the mineral's geometry as a guide. It's a small glimpse of what the early Earth might have done naturally. If that's true, then life wasn't a sudden miracle. It was a phase transition. So the next time you look at that elegant double spiral called DNA, remember that you might be looking at the universe's oldest pattern, written once and written again in us. The Great Pyramid and Earth's Schumann resonance. Rising from the Giza Plateau, the Great Pyramid has stood for more than 4,500 years. Weighing nearly 6 million tons, it's built from over 2 million limestone and granite blocks, each placed with astonishing precision. For centuries, its purpose has been debated, but in recent decades, researchers have uncovered another property, one that has nothing to do with geometry or alignment, but with sound and resonance. When low-frequency sound waves are introduced into the pyramid's chambers, certain frequencies amplify. It's as if the entire structure is tuned, like a vast stone instrument. In 2018, a study published in the Journal of Applied Physics modeled how the Great Pyramid interacts with electromagnetic waves. Using simulations, researchers from Russia and Ukraine found that the internal cavities, particularly the King's Chamber, can trap and focus energy at distinct resonant frequencies. One stood out, around 7 to 8 Hertz. That number isn't arbitrary. It's almost identical to Earth's natural electromagnetic resonance, the Schumann resonance, measured at 7.83 Hz. The Schumann resonance was first identified in 1952, when physicist Winfried Otto Schumann calculated that the space between the Earth's surface and the ionosphere acts like a global resonant cavity. Every lightning strike feeds that cavity, creating a standing wave that circles the planet continuously. In effect, the Earth hums imperceptibly at 783 Hz. What makes this frequency remarkable is that it also aligns with the alpha wave rhythm in the human brain, the calm meditative state between waking and sleep. To find the same frequency echoed inside one of humanity's oldest and most precisely built monuments was, at the very least, unexpected. Was this resonance intentional? Could ancient engineers, without electricity or modern instruments, have somehow designed chambers that amplify the planet's fundamental tone? Or is the alignment a coincidence, an artifact of geometry and proportion? Skeptics point out that the pyramid's resonance spectrum includes multiple frequencies and that the 7.83 Hz match is approximate. But even that doesn't erase the measurable fact. The pyramid does resonate. Its chambers act like resonant cavities, concentrating energy in specific zones. The Journal of Applied Physics study confirmed this through electromagnetic modeling, showing energy density patterns that peak inside the king's chamber. It's not evidence of mystical design, but it is a verified example of resonant behavior in a 4,500-year-old structure. And the pattern doesn't stop at Giza. Across the ancient world, in Stonehenge, Malta's Hypogeum and Newgrange, acoustic engineers have recorded unusual amplification of low-frequency tones. Different cultures, separated by oceans and millennia, built spaces that seem to respond to the same narrow frequency band. Whether by observation, intuition, or accident, ancient architects may have tapped into a physical truth that matter, shape, and vibration are deeply intertwined. The Dead Sea Scrolls and the Book of Isaiah. It starts in the barren cliffs above the Dead Sea, at a place called Qumran. A Bedouin shepherd, searching for a lost goat, throws a stone into a dark cave and hears the sharp crack of pottery breaking. When he climbs inside, he finds clay jars sealed tight, wrapped in linen. Inside the jars are ancient scrolls, dry, fragile, but still intact. Archaeologists soon arrive, realizing this is no ordinary discovery. The scrolls date from the Second Temple period, written between 200 BCE and 70 CE. Among them is one manuscript that stands out immediately, a nearly complete version of the Book of Isaiah. The world would come to know it as the Great Isaiah Scroll. When scholars compared it to the Masoretic text, the Hebrew version used for over 1,000 years, they expected differences: missing lines, reworded passages, centuries of accumulated change. But what they found instead was astonishing. Across more than 50 columns of text, the wording was almost identical. 1,000 years of transmission, and only a handful of spelling variations. No missing verses, no rewritten theology. The discovery challenged long-held assumptions about how ancient texts evolve. How could a document survive wars, exiles, and endless human error, yet remain nearly untouched? Some saw it as proof of extraordinary discipline within the scribal tradition. Others believed it was something more: preservation guided by intent, even by faith. The science behind it added weight to the mystery. Carbon dating confirmed the scroll's parchment was made around 125 BCE. Infrared imaging revealed multiple scribes had worked on it, carefully layering ink so the text flowed seamlessly, their handwriting nearly indistinguishable. Linguistic analysis found that the language structure, grammar, and idioms matched later Hebrew versions almost perfectly. It wasn't a coincidence. For historians, this was revolutionary. For believers, it was validation that what had been written was never forgotten. Today, the Great Isaiah Scroll rests inside the shrine of the book in Jerusalem. Digitized in stunning resolution, every crack and character can be viewed by anyone on earth. It remains one of humanity's rarest achievements, a text that crossed 2,000 years almost unchanged. Across empires, languages, and centuries, its message endured. Not just because it was written, but because generation after generation refused to let it fade. Newton and the harmony of the cosmos. In 1687, Isaac Newton published Philosophia Naturalis Principia Mathematica, the book that defined motion, force, and gravity for the modern world. To most, Newton was the ultimate mechanic of the cosmos, a man who turned the heavens into equations. But behind the public image of a rational scientist was another Newton, one obsessed with alchemy, theology, and the search for a hidden order that linked matter and music. Across thousands of manuscript pages now preserved in the Cambridge University Library, Newton wrote of the divine ratios that governed the material world. He believed every orbit, every beam of light, and every element pulsed according to a mathematical rhythm, a harmony that revealed the mind of its creator. For him, the universe wasn't a static clock, it was an instrument, and gravity was the tone that held its music together. This wasn't an entirely new idea. Half a century earlier, Johannes Kepler had proposed something similar in Harmonices Mundi, the harmony of the world. Kepler believed that the planets moved in musical intervals, forming chords as they orbited the sun. When Newton studied Kepler's work, he took the metaphor further, asking whether the harmony could be expressed not in notes, but in numbers. In his letters to Robert Boyle, Newton wrote that metals, planets, and even the colors of light followed proportional laws, each related through geometry and frequency. The same mathematical ratios that determined a musical scale, he believed, shaped the architecture of nature itself. For centuries, these writings were dismissed as the eccentric side of a genius, the relics of a mystic hidden beneath a physicist's mind. Yet, over time, the science began to circle back. In the 20th century, astronomers discovered orbital resonances that mirrored the very harmonies Newton described. The moons of Jupiter, for example, follow a 1-2-4 orbital ratio, each completing its path in perfect synchronization, like a cosmic chord repeating through space. In the world of atoms, quantum physics revealed that electrons occupy discrete energy levels, their positions defined by vibrational frequencies. And in modern theoretical physics, string theory proposes that all matter arises from minuscule vibrating filaments, each particle a different note on a universal string. In a sense, Newton's metaphor had become literal. The cosmos really does make music. We just learned how to listen. In 2015, the LIGO Observatory recorded the first gravitational waves, ripples in space-time produced by colliding black holes. Their frequencies weren't random. They formed measurable oscillations, a distinct fading tone that physicists nicknamed the ringdown. For the first time, we were hearing the vibration of the universe itself, and it didn't stop there. The cosmic microwave background, the oldest light in the universe, carries within it the remnants of sound waves from the first 380,000 years after the Big Bang. NASA's WMAP and Planck missions mapped those oscillations, pressure waves that rippled through the early plasma, and found that they followed precise harmonic patterns. The same kind of symmetry Newton believed tied matter and motion together was written into the fabric of the cosmos from the very beginning. Today, researchers call this field resonant cosmology, the study of how structure, from galaxies to atoms, emerges from oscillation and feedback. The principle is simple. Everything that exists vibrates. Every vibration has a frequency. Every frequency fits a pattern. Newton's universe, the great celestial machine, wasn't silent after all. It was mathematical harmony made visible, a system where every orbit, every photon, every atom plays its part in a continuous symphony of motion. More than 3 centuries later, the idea he carried quietly in his notebooks feels almost prophetic, that the laws of physics are a rhythm. The Earth-Mars cave networks. In Hawaii, the Kazumura cave winds more than 40 miles underground. In Iceland, entire networks branch through basalt hills, perfectly arched, naturally insulated, and preserved for thousands of years. Temperatures remain stable. Structures stand without collapse. These formations are so robust that NASA now studies them as natural blueprints for extraterrestrial habitats. Because somewhere else in the solar system, the same structures exist. In 2007, the Mars Reconnaissance Orbiter captured a set of images near the giant volcano Asia Mons, massive circular depressions on the Martian surface. Each looked like a collapsed skylight leading into something deeper. Later data from the Mars Global Surveyor confirmed that these voids could extend for kilometers underground, the telltale signature of ancient lava tubes. In the thin Martian atmosphere, they've remained sealed for millions of years, untouched, protected from radiation and possibly from time itself. On both Earth and Mars, the physics are strikingly consistent. The tubes form when flowing lava cools and hardens at the surface, while molten rock keeps moving below. As the flow drains, it leaves behind a hollow passage, an arched shell of volcanic stone. Despite the difference in gravity, pressure and temperature, both planets produce tunnels with identical curvature ratios, as if sculpted by the same invisible hand of physics. Geologists call it gravitational scaling, the way rock flow dynamics adjust to planetary mass. Even so, the precision of the match remains astonishing. A 2018 study in the Journal of Volcanology and Geothermal Research found that Earth's lava tubes and Martian tubes could be modeled using the same fluid dynamics equations, producing the same proportional outcomes. The odds of that kind of geometric convergence, formed independently on two worlds, continue to puzzle researchers. Infrared readings added a new layer to the mystery. In 2010, orbital thermal imaging detected subtle heat signatures around some of Mars's cave skylights, temperatures several degrees warmer than the surrounding surface. On a frozen planet averaging -60 degrees Celsius, that warmth stood out. It could be geothermal residual heat, or it could suggest a thermal buffer zone capable of sheltering life. If microbial life ever existed on Mars, these tubes would have been the perfect refuge, shielded from solar radiation and cosmic rays, insulated by rock, and perhaps still harboring pockets of trapped moisture. For exobiologists, that possibility is more than theoretical. Some now believe that extremophile microbes, like those found deep in Earth's volcanic caves, could survive in Martian tunnels, dormant for eons but still chemically active. On Earth, microbes thrive on the walls of lava tubes, feeding on trace minerals and water vapor. Their existence proves that life doesn't need sunlight, only chemistry. If Mars followed the same rules, those caves might not be dead, just quiet. Visually, the resemblance is uncanny. Cross-sections of Kazumura Cave in Hawaii align almost perfectly with those of the Asia Mons skylights. Their height-to-width ratios differ by less than 3%. Two planets, two atmospheres, same geometry. To planetary geologists, that's evidence of universal physics. To origin-of-life researchers, it raises the thought that if geology can repeat across worlds, maybe biology can too. That's why NASA and the European Space Agency are preparing the next phase. The Mars Ice Mapper and ExoMars rover will use radar and ground-penetrating sensors to scan for subsurface cavities and organic molecules. If they find complex carbon compounds, or even fossilized microbial traces, it would mean that beneath the Martian dust lies not just geology, but memory, a record of how matter organizes itself in familiar ways, even light years apart. The Earth-Sun distance. On average, Earth orbits the Sun from a distance of about 149.6 million kilometers, roughly 93 million miles. The Sun's diameter, about 1.39 million kilometers, or 864,000 miles. Divide the distance by the diameter, and the ratio comes out close to 108. That alone might sound like a neat mathematical curiosity, but the coincidence doesn't stop there. Look at the Moon. Its average distance from Earth is about 108 times its own diameter. Because of that, when the Moon passes between us and the Sun, their apparent sizes match almost perfectly. That's why total solar eclipses can happen at all. From our vantage point, the Sun and Moon appear nearly the same size in the sky, a rare alignment written into the geometry of our solar system. Was that symmetry just luck, or part of a pattern? For centuries, the number 108 has held deep symbolic meaning in cultures around the world. In Hinduism, there are 108 Upanishads, 108 names of Shiva, and 108 energy points said to run through the human body. In Buddhism, A strand of mala beads always has 108 beads, one for each worldly desire to overcome. Ancient Indian temple builders measured steps, corridors, and sanctum angles in multiples of 108. According to studies from the Archaeology magazine and Smithsonian Institution, similar ratios appear in temple designs from Angkor Wat to Borobudur. It's as if ancient architects recognized a cosmic number, long before they had the means to measure it. Mathematically, 108 is also elegant. It's the product of foundational building blocks. It's a number that balances symmetry and structure, showing up again and again in systems that humans create and admire. But here's the twist. Nature seems to use it too. Some physicists argue it's all anthropic coincidence, that humans evolved to notice pleasing patterns in the numbers surrounding them. The geometry fits, they say, because we're looking from a perspective where it does. Others see something more. A few astrophysicists have proposed that planetary distances might self-organize into harmonic relationships, resonances that echo through orbital mechanics. If so, then maybe 108 isn't mystical at all. Maybe it's mathematical, a reflection of how the universe balances forces and motion on a cosmic scale. Still, the pattern is hard to ignore. Earth to Sun, approximately 108 x-Sun diameter. Earth to Moon, approximately 108 x-Sun diameter. And because of that, we live in one of the few known systems where eclipses align perfectly, just enough to inspire wonder and myth across time. It's one of those coincidences that makes the universe feel tuned, even when reason says it's random. Modern astronomy explains it all through orbital mechanics and evolutionary timing, yet the number remains, bridging our cosmic position, our spiritual architecture, and our perception of the sky. Coincidence, maybe, but one so elegant it almost feels intentional.